Hi guys! Today we're going to be going over 9.1, which is the midpoint and distance formulas. The reason why we're not doing a lesson in class on this is because it's pretty simple material that I know you've seen before. So there's not even going to be homework on this section. It's just going to be make sure you watch it and understand what's going on. Alright, so the formulas for midpoint are if you have two endpoints, the midpoint is going to be your x-coordinates added together over 2. That's going to be the x-coordinate of your midpoint. And then the y-coordinate of your midpoint will be the y-coordinates added together divided by 2. Makes sense why it's divided by 2, because the midpoint's halfway between the two endpoints. The distance formula is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. It does not matter what your x2, y2, x1, y1 points are, but you need to stay consistent. So for example, if I had 2, 3 and 4, 5, if I decide these are my 1 points, those need to be x1 and y1, and these would have to be x2 and y2. I can't mix like y2 with x1, okay? So that's our midpoint and distance formula, which you will need to memorize. And now we're just going to do some problems with those. So our first example says find the coordinates of B, the midpoint of AC. Okay, so then it tells us what A and C are. A is 5, 2, and C is 7, 8. Okay, so we are looking for B, which is the midpoint. So we're just going to use our midpoint formula, which is x1 plus x2 divided by 2, and y1 plus y2 divided by 2. Okay, I'm going to say these are my first points and these are my second points. So I'll have 5 plus 7 over 2, and I'll have 2 plus 8 over 2. Okay, so that's going to give me 12 over 2 and 10 over 2, which simplifies to 6, 5. Okay, and that is my midpoint, 6, 5. All right, make sure you understand that, and then pause the video and try the checkpoint on the next page. Once you have your answer, come back and watch the video. Okay, it asks, what are the coordinates of the midpoint of the segment with endpoints 3, 6, -1, -8? So I'm just going to have 3 plus -1. Okay, be careful with those negatives. Divided by 2. And 6 plus -8 divided by 2. Okay, so I'll have 2 over 2, which is 1. And I'll have -2 over 2, which is -1. So my midpoint would have been 1, -1. All right. Now we have another example. It says Matt's disc is 3 feet short and 2 feet to the right of the basket. Okay, on his first put, the disc lands 4 feet beyond the basket and 1 foot to the left. If the disc went in a straight line, how far did it go? All right, this is kind of hard to make sense of right now, so let's draw a picture. So what I am going to do is make the basket what we're aiming for 0, 0. Okay, so on a coordinate plane, I'm going to make that. All right, I'm going to put a red dot where I think the basket is at 0, 0. Okay, so this is the basket at 0, 0. Now I need to graph these other points that they give us. So the first point is 3 feet short and 2 feet to the right of the basket. All right, well, 3 feet short is going to be -3, 1, 2, 3. And 2 feet to the right is just going to be 2 to the right. So that coordinate is 2, -3, right? 2 to the right and 3 feet short. On his first put, the disc lands, let's see here, 4 feet beyond the basket and 1 foot to the left. All right, 4 feet beyond, that's 4 feet above. 1, 2, 3, 4. And 1 foot to the left, so that's -1. So that's -1, comma 4. Okay, so if the disk went in a straight line, all right, so we know our endpoints are in a straight line here. How far did it go? Okay, so now we need to figure out the distance between these 2 points. All right, so we need our distance formula. So distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, so we'll just plug in our points. I'll say my blues are my first points and my purples are my second points. Okay, if you did it the other way, that's totally fine. So we have D equals the square root of 4 minus, oops, sorry, those are my y's. It's going to be -1 minus 2 squared, okay, and plus 4 minus -3 squared. So distance equals the square root of -3 squared plus 7 squared. Distance equals the square root of 9 plus 49. So distance equals the square root of 58. So our final answer is D equals square root of 58. Okay, that is the distance that my shot went. Okay, go ahead and pause the video and try the next one. All right, so a coordinate grid is placed over a scale drawing of Nita's patio. A grill is located at 2, -3. So I'm immediately going to start drawing that. So it's at 1, 2, -3. So that's 2, -3 is the grill. A flower pot is located at -6, -1. Okay, so that's -6, -1, and that is my flower pot. Okay, I have my flower pot labeled at -6, -1, and my grill labeled at 2, -3. A picnic table is halfway between the grill and the flower pot. In coordinate units, about how far is it from the grill to the picnic table? All right, so we know we're going to go in a straight line here. And we are trying to figure out where our table is, right? And it says our table is halfway between the grill and the flower pot. Okay, you might have started out doing the distance formula, but what other formula do we know that tells us the point that's right in between 2 other points? The midpoint formula. So we really don't need distance here. So we can just have our x2 plus x1 over 2, comma, our y2 plus y1 over 2. And we can plug in our points, which are -6 plus 2 over 2, and -1 plus -3 over 2. Okay, that's going to give us -6 plus 2 is -4, so we have -2, comma, and -4 divided by 2, -2 again. Right, and that actually looks about right if we look at our rough sketch to the left there. So our table is located at -2, -2. Okay, if we would have used the distance formula, it would have only given us the distance. It wouldn't have given us the exact point. Another skill you're going to need throughout this chapter is completing the square. Okay, so we're going to just take this time to review 2 examples of completing the square. All right, so first off, this should be x squared plus 3x equals 18. The first step is to move the c value to the other side, if you recall. So step 1 is to move c value to other side. Luckily, they already did that for us, so we're good with x squared plus 3x equals 18. Okay, now if anyone remembers step 2, we're going to add something to both sides. We're going to add b over 2 squared to both sides. Our b term in this case is 3, so we're going to add x squared plus 3x plus 3 over 2 squared to both sides. Now take a second to think about completing the square. What would we have had to do before adding b over 2 squared to both sides if there was a number here? Okay, if there was a number or an a value, remember we would have had to divide everything by a first. Okay, luckily this one did not have an a value, okay, so we didn't have to do that. Now we want to simplify a little bit, so we have x squared plus 3x plus 9 over 4 equals 18 plus 9 over 4. Okay, and now we can factor the left side. Remember, it's always going to factor to x and then plus or minus whatever term this was. Okay, so that's a positive term. Remember, it's always going to be x plus whatever this term is. So if that was a negative 3/2, it would be x minus 3/2. But since it's a positive 3/2, we're just going to do x plus 3 over 2 squared. That's why it's called completing the square. It'll work every time. Equals 18 plus 9 over 4. Okay, so that was step 3, was to factor left side. All right, now step 4 is just going to be to actually solve for x. So step 4 is solve for x. So I'm going to go ahead and copy my equation so I can put it up here. Okay, so first thing I'm going to have to do is combine these numbers over here to the right. So we have to multiply 18 times 4 to get it over 4. Okay, that's going to be about 72 over 4 plus 9 over 4. Okay, so that equals 81 over 4. Okay, and our left side just stayed the same while we were doing that. Now, does anybody remember how to undo the square? Okay, take a second, think about it. All right, to undo a square, we have to just take the square root of both sides. Okay, so we get x plus 3 over 2 equals, do not forget your plus or minus. Okay, what's the square root of 81? 9, and square root of 4 is 2. Last thing is to subtract 3 over 2, so we get x equals plus or minus 9 over 2 minus 3 over 2. And those are your two solutions. And that's completing the square. All right, so first we move the c to the other side. Remember, divide by a if there is one. Okay, that's an important part as well. Step 2 is add b over 2 squared to both sides. Step 3 is to factor the left side. Remember, it'll always factor to x plus whatever number was b over 2. Okay. If b over 2 is negative, it would be x minus that number. And step 4 is to solve for x, which is going to be by taking the square root of both sides. And that's it. Go ahead and try the next example, and then we'll go over it. All right, so find the solutions of x squared equals 4x minus 1. The first thing I should do here is get my c term isolated. So we got x squared minus 4x equals negative 1. There's no a term, so we don't have to divide. So we can just add 4 over 2 squared to both sides. That's adding my b term over 2 squared to both sides. I already know exactly what my left side's going to look like. Oops, I forgot my negative. So I know it's going to be x minus 4 over 2 squared. And my right side is going to be negative 1 plus negative 4 over 2 squared. Okay, we can simplify. So x minus 2 squared is on the left, and we're going to have negative 1 plus negative 4 over 2 is negative 2 squared, so plus 4. X minus 2 squared equals 3. Take the square root of both sides. X minus 2 equals plus or minus the square root of 3, and add 2. So x equals plus or minus square root of 3 plus 2. And those are our two solutions. All right, I hope you remember completing the square. If you don't, you're definitely going to want to go back in our notes. I think that was chapter 5, and refresh yourself on what we were doing there. Or you can talk to me if you had trouble with this lesson. Otherwise, there's some suggested practice in the book on what we learned about midpoint and distance formula. But if you feel confident in what you're doing and you know the formulas, you really don't have to do that suggested practice. All right, that's it for section 9.1. All of these skills are little tools that we're going to need throughout chapter 9. If you have any questions, be sure to let me know or shoot me a message. Okay, have a great day.